Okay, so in this video we'll be looking at the x-intercept method for solving an equation. There are lots of different ways of solving equations. The one that we're going to look at in this video is a linear equation. And the method of the x-intercept method is one of different techniques used for solving various equations. We're going to use the x-intercept method to find the solution to a linear equation. And the method works by finding where a graph of a related function to the equation that we're solving crosses the x-intercept. That's why it's called the x-intercept method. And although this method can be done algebraically, our approach will be to use a graphing calculator to solve this using the graphing calculator, and also to give you some more practice with using the graphing calculator to solve problems in this class. So here I've brought up one of the homework problems from Course Compass, and this is in the section 3.1 where the x-intercept method is covered. This is part of the review material, and I'm solving problem number 7 in this homework section. So the equation in front of us is right here. It's a little hard to see, so I'm going to bring up the equation that says 3x minus 1 over 8 minus 4x is equal to 1/4 plus 7x plus 4 over 12. And we're going to use this solving the x-intercept method. Okay, now before I do this, I'm going to go ahead and bring up the equation again here so you can see it. So let me bring it up right now and bring it into the screen. And so now the equation we're solving a little bigger to see on tinier view screens at home. It's 3x minus 1 over 8 minus 4x equals 1/4 plus 7x plus 4 over 12. And the way I'm actually going to enter this equation into my graphing calculator, since I don't have vertical fraction bars on the graphing calculator, I'm going to actually enter it when I solve it on the graphing calculator. I'm going to enter it as an expression. I'm going to let y1, so the first thing I do is I'm going to bring and it doesn't matter which side you do this to, but since you're finding the x-intercept, the first step is always to set one side of the equation equal to 0. So here I've subtracted 1/4 from both sides, and then subtracted the term 7x plus 4 over 12 from both sides, and then I set one side equal to 0, and that's important because that's going to be the first step in using the x-intercept method. So the expression that you get on the left, in this case 3x minus 1 over 8 minus 4x minus 1/4 minus the quantity 7x plus 4 over 12, that quantity is going to actually be graphed on the graphing calculator as y1. And where the graph crosses the x-axis, well, when you cross the x-axis, y is equal to 0. So where the graph of that function crosses the x-axis will also have an x value. Since we're solving for x, we'll have the x value, the x-intercept for the graph that satisfies this equation, that solves this equation. And this second equation is equivalent to our first equation. So our approach is to set one side equal to 0, graph the non-zero expression, in this case on the left, find the x-intercept, and then we'll check our solution at the very end and make sure that we've done all our work so far. So that's our approach in solving the equation. So let's go ahead and bring back Course Compass. And the next thing I want to do is I'm going to go ahead and, as I said a second ago, I want to set one side of the equation equal to 0 and then enter the other expression as y1. So bring up my graphing calculator here. And okay, I think that's probably good right there. All right. So I'm pressing y equals, and so the first step is to enter that expression that we saw just a second ago. Let me bring that up here, and then you can see everything here. So I'm going to enter the expression 3x minus 1 slash bar 8 in my graphing calculator. So the expression in the second equation on the left. So here we go with the parentheses. 3x minus 1 divided by 8. And it doesn't matter which side you set equal to 0. I just decided to set the right side equal to 0. You could have easily have brought the other two terms over from the left side and set the left side equal to 0 and then graph whatever is on the right. So it's up to you which side you set equal to 0. So now minus 4x. And then minus, and notice I'm using the minus key above the plus key here for subtracting. If I want a negative number, then I use the minus key on the bottom, so I don't want to use that here. So we have minus 1/4, and then minus, and then I have, I'm taking a negative of of a sum, so I need parentheses here. This is a very common mistake when people do these problems. Plus 4, close the parentheses, and then I'm going to divide by 12. And I'm just going to go ahead and press enter here and then check my expression. So 3x minus 8, 3x minus 1 over 8 minus 4x minus 1/4 minus the quantity 7x plus 4 divided by 12. So that's what I'm going to graph on my graphing calculator. Now, you can use any of the windows on the graphing calculators. One of the windows I like trying is I'm under the zoom menu over here. I'm going to press on the zoom menu. And there's two built-in windows that I like using. I often try the zoom decimal window. That's a smaller window that goes from about -5 to 5 on both axes. And then there's also zoom standard. That window goes from -10 to 10 on the x and the y axis. And these are built-in windows, so I don't have to go to the window button over here and then specify the x, min, and max values for my graphing calculator window. So I'm going to go ahead and use my down arrow to highlight zoom decimal and see what I get. And then if I don't like this, I can always adjust my window. And then I'm going to go ahead and press graph, and the line on the left should graph. This actually is not the zoom decimal window, so something happened here. Let me go back and do this again. Press 4. I'm going to press, I guess I pressed graph. I should have selected enter to choose 4, or just type 4, zoom 4. So I should have pressed enter. That's what happened. So that's more like it, I'm expecting. So you can see the graph crossing. There's an x-intercept there, but it's kind of hard to see on this window. So here I'm going to go ahead and make an adjustment, and I'll show you another feature of the zoom setting that's pretty nice for this kind of problem. So I'm going to go to the zoom menu here, and I'm going to choose number 1 zoom box. So I'm going to press enter since that's zoom box. And what I'm going to do here is with my arrow keys, I'm going to highlight and I'm going to move the cursor. You can see it blinking there. What I'm doing is I'm going to be setting the upper left corner of a box that's going to become the new graphing calculator window. So you can actually do this on the graphing calculator. So that's going to be the upper left corner. So I'm going to press enter there once to set that corner. And then I'm going to use the down arrow and then the right arrow, and then you're going to see a box appear, and then that box actually becomes the new graphing calculator window. And the nice thing about this is you don't have to worry about figuring out what the numbers are for the window. You just sort of create the box around the portion of the graph you're interested in. And then when you've got that second diagonal corner set, you just press enter, and then that's going to be our new graphing calculator window. So let's go ahead and press enter. And now what I'm looking for here is I want to see a definitive place where the graph crosses the x-axis. So now what I need to do is find where that x-intercept is, and that x-intercept is going to solve my original equation. So the next step is I'm going to go over here to the calculate menu above the trace key, and to get that I'm going to use the second function over here on the left. So I'm going to press second and then trace, but I'm actually entering into the calculate menu. And I'm going to scroll down here to 0 because in function terms, 0 of a function is an x-intercept. So the 0 of the function y1 that I'm graphing is where the graph crosses the x-axis. So I'm going to press enter. Now what it's asking for me up here says left bound. So what I'm going to do is I'm going to go ahead and use you can use the left or the right arrows. What I want to do is I want to move the arrow until I see a little cursor character, and there it is. You can see it coming up there. It looks like a little crosshatch there. Right here blinking, and left bound. So what I have to do is I have to move that cursor until it's to the left of where the graph crosses the x-axis. Anywhere to the left is fine, but make sure it's to the left. So the x value of that point on the cursor is to the left of where the graph crosses the x-axis. And then press enter once, and that's going to set the left bound of an interval that contains your 0. So now it's asking me for a right bound, so I'm going to use the right arrow. And I'm going to move the cursor until it's just to the right of where the graph crosses the x-axis, and that's good. So the x value of the point on the cursor is to the right of the x value of my x-intercept, and then I'm going to press enter a second time. So go ahead and do that. Now what these two symbols are here, these two triangles pointing at each other, are defining below them an interval that contains the x-intercept. So if you've done this right, where the graph crosses the x-axis should lie between these two triangles that you see above. Now, it's asking for a guess, but since there's only one place where it crosses the axis, I'm just going to go ahead and press enter again, and then the calculator will numerically calculate the value of that x-intercept, and it gives me a very exact value there, as accurate as the calculator can get it. And sometimes it's exact, and if it's not exact, it'll be very close to the true value. So let's press enter. So I'm pressing enter. I've actually pressed enter 3 times now. And so the calculator says x is equal to negative 0.1683,168. So that's the approximate x value, but I can do a little better than this. So what I'm going to do now is I'm going to leave this screen, and you want to do this immediately after you find the x-intercept. So I'm going to hit second quit and just clear what's in there. And if I press X now, you can see X right here next to the green alpha button. And I press enter, that memory register actually stores that value of X, and it has all the decimal places there. Now sometimes, you can't always do this, sometimes like if you want to give an exact value for that decimal, if the calculator converts the decimal to a fraction, it can give you an exact fraction that gives you the exact value of this decimal. If it gives you the decimal back after we do this, that just means that it can't convert it, and the best we can do is work with this very good approximation. So to try to convert this to a decimal, what we're going to use is the math button over here. So I'm going to press math. And then I'm going to select 1, or since 1 is selected, I'm going to choose enter. And that's what this is saying is this says convert to fraction. So I'm going to press enter. Now answer is referring to the value that we just got for our value of x. So that's the preceding value that was in the display. That's stored as answer. And then the caret means convert to fraction. So this says try to convert answer to a fraction. And then the fraction represents the exact value of that decimal. So that decimal is actually 17 over 101, negative 17 over 101. And I can use the fractional form here if I like for the exact value instead of having to use all the decimal places. Or if, depending on what the problem asks, I might need to use a decimal approximation. So in either case, these are different ways of representing the value that's the solution to our original equation. So if we go back to our original equation, this value of x, either in fractional or decimal form, should satisfy 3x minus 1 over 8 minus 4x is equal to 1/4 plus 7x, 1/4 plus the quantity, 7x plus 4 over 12. So when I substitute for x, I should get a true statement. And I'm going to go ahead and check this on my graphing calculator and make sure this works. So let's go ahead and check. Since this value is stored in memory right now, I can go ahead and type. Now, what I like to do is I like to work with the left side of the original equation and the right side of the original equation, because when you move the terms around, you might make a mistake, and the second equation here might not be the same as the first equation if I make a mistake. So my personal preference when checking is to always check the original equation before anything was moved around, and then you're guaranteed to be working with your original equation. So let's go ahead and check this now, and the graphing calculator makes this a snap too. So on the left side, again, to enter that fraction 3x minus 1 over 8 on the graphing calculator, I need parentheses. So I'm going to use a parentheses, 3x. And see, x now currently stores that value that we just computed. And it's important that you do this immediately after you find your x-intercept, because when you graph again, the calculator overwrites that value of x and changes it. So you always want to do this immediately after you find that x-intercept. And then we're going to subtract 4 times x. So I'm just typing 4x. So that's the left side of my equation using a slash bar for a fraction. I'm going to press enter. Now if this does satisfy my equation, when I plug in that same value of x on the right side, I should get the same value. So I'm going to take 1/4 plus, and then the parentheses, and then 7x plus 4, close the parentheses, and divide by 12. And if this does satisfy my equation, if it does solve my original equation, I should get the same decimal here on the left and the right. So let's see if that works. Okay, so I've got exactly the same decimal. I know that that value of x satisfies my equation. If I want to get x again, I just press x as a reminder. So it's about negative 0.168. And now I'm sure that I've got a solution to my equation. So I'm in really good shape now, and I'm ready to go to Course Compass and go ahead and check my work. Okay, so back to Course Compass here. So there's our original equation up on top. You can see it up here. And it says select the correct choice below. Fill in any answer boxes with your choice. So it says A, x equals, type an integer or a decimal. And it asks for a decimal to 2 places. So you have to be careful with Course Compass. Now we did actually get a solution here. When you cross the x-axis once, then you have one solution. So And now my value of x, it's asking for rounded to 2 decimal places. So let me bring my calculator up. So to 2 decimal places, this is going to be negative 0.17. Okay, so that would be rounded to 2 decimal places. The second decimal place is a 6. The value to the right is 8, so this would be negative 0.17. So let's go ahead and enter that for x, and then we'll go ahead and check our answer. So minus 0. You don't have to type 0, but I'm going to go ahead and do that. I'm just going to go ahead and double check this for a moment. Negative 0.17, and that's the rounded value to 2 places. Okay, that looks good. And then the last thing I'm going to do down here is I'm going to check my answer and make sure. And again, be careful with Course Compass. Sometimes Course Compass wants fractions. Sometimes it wants decimals. And when it asks for decimals, they'll often ask for decimals rounded to a certain number of places. And if you don't round it to the correct number of places, it'll mark the answer wrong when you probably had the right answer. And that's going to seem unfair. And maybe it is unfair, but remember, this is being Course Compass is programmed by programmers, and the programmers have to put your answers in a form that they can write software to identify your answers. So that's part of why you sometimes will see these special case conditions and the special formats for the answers when they're entered in Course Compass. So just be aware of that so you don't lose any points that you don't need to lose. So okay, so let's go ahead and check our answer, make sure we got the right answer, and if we did, then we're set. So let's see what we get. Okay, so it says, good job. I've got the right answer, and now I'm done. So that's it. That's the x-intercept method for solving an equation. If we just quickly go back and review what we did, we started with our original equation here. We set one side equal to 0 by moving terms on the left or the right side to the other side so that one side is equal to 0, so I form an equivalent equation. The side that's not equal to 0 gets graphed as y1 as we did on our graphing calculator. So on the graphing calculator, we find the x-intercept of the graph. We did that using the second calc menu. And then we selected 0, number 2 for 0, to find that x-intercept. And then again, we chose a left bound and pressed enter. And then we used the right arrow to trace to a right bound, press enter. And then press enter a third time, and we got negative 0.168. We rounded that to 1 decimal place. 2 decimal places for our answer, and then in the window up here we checked our answer using the calculator. So you can always check on the calculator using memory registers. The calculator makes checking equations super easy, and you should always check your solutions. It's just so easy on the calculator, there's no excuse not to do it. And we got our answer, we checked it in Course Compass, and everything's good. And that's the end of this video. So that completes the video on the x-intercept method of solving equations.